Okay, pre-calculus kids. Like I said when we went over this in class, 8.4 and 8.5, I'm just running it like it's one big section. So I'm going to give you the notes for 8.5. It's only going to be one quick little video, less than 15 minutes. I'm going to give you some more examples. Same stuff. The difference from 8.4 to 8.5's lesson is that in 8.5 is when I'm supposed to tell you, hey, now we're only going between 0 and 2 pi, 0 and 2 pi. Again, for our class, I want you to, if they use x, and I'm going to switch some of these over to theta. If they use x, we're going to keep it in degree mode, 0 to 360. If they use theta, we're going to go 0 to 2 pi, just so that we have a mix of sometimes using degrees, sometimes using theta. We're going to go back to using our unit circle to answer a whole bunch of these. So you have a homework assignment that was due from section 8.4. That was due already. And now here's the notes for 8-5. Solve for 2 cosine x minus square root of 3 equals 0 over the interval 0 to 2 pi. So when they do tell you what the interval is, it says including 0 because of the bracket up to 2 pi. So let's say 0 was the solution. You would say 0 is the answer and not 2 pi. I know that happened in one of our examples in the other homework, and that was because I was really introducing this concept before we were supposed to be doing it. All right, so it says you go from 0 to 2 pi. So for this one, let's make it theta instead of just plain old x. We're going to do the same stuff we did before. I'm going to add the square root of 3. I'm going to divide by 2. So if I add root 3, divide by 2, I get square root of 3 over 2 on the other side. Right away, I know that my x is positive, right? Positive fraction. So we're in quadrants 1 and 4. And this is the long leg of 30, 60, 90. Picture what that looks like. Short leg is the y number. This is a square root of 3 over 2. It's a 30-degree reference angle. That would be one of the answers if it was in degrees, but they wanted radians here. So we're going to go, theta is going to equal 30 degrees. And then when it wraps all the way around to here, it's going to be, oh, wait, dang it. We don't want degrees at all. I'm doing this wrong. I just said not to use degrees. Pi over 6 and 5 pi over 6. All the way around would be 6 pi. No, not 5 pi over 6. Gosh dang it. Pay attention to what I'm doing here. It'd be 11 pi. This is 2 pi, right? So over 6, that would be 12 pi. That would make this 11 pi over 6. Holy cow, Mr. B, wake up. I'm drawing in the right spot. I'm just not writing down the correct radians when I'm doing this. Let's make this one an x problem. So I'm going to say between u0 up to 360 degrees. We'll keep it that way. Tan squared x minus tan x. We've had this one before. Take out a tan x. And you're left with 1 minus tan x. All right, we're going to take this, set it equal to 0. We're going to do this, set it equal to 0. I get tan x. So we want solutions where tan x equals 0 and when tan x equals 1. Two totally different scenarios to have to think about. Let's talk about the first one. Tan x equals 0. Now remember, tan is sine over cosine. Another way to think of it is the y number over the x number. And the only way that can come out to be 0 is if it's a 0 on the y number. Not on the x number, but on the y number. This can be 1 or negative 1. Doesn't matter. But what I'm getting at is the only time when the x is 0 is when you're here and here at 1 and negative 1. So this has solutions of 0 degrees and 180 degrees. 1, 0. Think of the unit circle. Negative 1, 0. When tan x equals 1, well, the only time that happens is when the y over the x divides and it's the same. And the only time that happens is when the legs of the triangle are the same. Square root of 2 over 2 or square root of 2 over 2. And that can be positive. I shouldn't say positive or negative. It should be both pluses or both minuses. And the only time that happens is here and here. Negative square root of 2 over 2, negative square root of 2 over 2. Positive square root of 2 over 2, positives. Those are the 45, 45, 90 triangles. So this one would be 45 degrees. This one would be 180 plus 45, 225 degrees. So x here is going to equal 225 and 45 degrees. So x is going to equal 0. I'll put them in order. 45, 180 degrees, 225 degrees. Woo! Got 2 examples down already. I'm going to put a couple examples on the back, so don't get excited. It's not going to be over in 5 minutes. Sine x, tan x, and then you got a minus sine x over this interval. We'll keep it in radians, so I'll pretend those are theta instead of x. Theta, theta, theta. Let's see. In this one, you definitely want to take a sine out. They both have a sine, see? You're going to take that out, you get tan. All right, now this is solvable. Tan x minus 1. We're going to set each one of these equal. This is a factor, that's a factor. Set them equal to each other. Sine x equals 0. Tan x minus 1 equals 0. We just did this problem up above. From above, I know x is going to equal, that was 45 and 225 in radians. Pi over 4, 4 pi over 4, 5 pi over 4. Over here, when does the sine equal 0? Well, it has to be on one of these axes. So when does, it's basically saying when does the y equal 0? And that's going to be here and, nope, I did that wrong. It's when the y equals 0. It's here and here. It's right, the same answers we got up above. Total coincidence. All right, so it's going to be at 0 radians and at pi radians, because it's 1, 0 and negative 1, 0. Oh, look at that. Look at that. They probably should have done that with cosine. Come up with some different answers here. All right, so what does theta equal? And I used x when I should have been using theta all along. Change it to theta, and I forgot to carry it out. All right, theta is going to equal, I forgot to write the answers here. 0 and pi. So it's going to be 0, pi over 4, then pi. And you don't have to put them in order. I'm just putting them in least smallest to largest angles. Just doing it in that kind of format. Let me give you a couple more examples. A couple extra examples. I got some more time on the clock before my video runs out. My videos run out when it hits the 15-minute mark, so to speak. That's when the whole app crashes. So let's try a different one. Let's go. I'll get one in. I don't know if I'll get 2 in. Let's see. Solve for theta. 3 secant squared x minus 4 equals 0. 3 secant squared x minus 4 equals 0. So you got to add 4 and divide by 3. Secant squared x is equal to add 4 divided by 3. 4/3 square root it. Secant x, not secant square root x. Secant x is equal to plus minus 2 on top, square root of 3 on the bottom. Now secant is really 1 over cosine. So I want to do the reciprocal of that and call that cosine. Gosh dang it, going back to x already. Cosine theta, and do the reciprocal over here. And that's now plus minus square root of 3 over 2. So that's the positive and negative long leg x number. It can be positive or negative. That gives me 4 answers. I'm in every quadrant now. Positive square root of 3 over 2. Short leg, here, here, and then negative square root of 3 over 2. Well, should look a lot more symmetrical than what I drew it. This would be like the 1/2, and the negative 1/2. And that is the way it would look. So In this case, that's going to be, let's see, 30-degree reference angles. That's going to give me theta equals pi over 6. Now I get the 5 pi over 6. That's 6 over 6, so that's 7 pi over 6. And then at the end, 11 pi over 6. Know your unit circle, people. Know your unit circle. Can I squeeze in one more? I'm going to try. I have one written down from last year. Let's see. Cosine x, I'll do 0 to 360. Oh, I'm sorry, bracket. From 0 to 360 this time. Forgot to do it up above. Cosine x plus sine x times tan x equals 2. I think we got to do common denominators here. We got too many different. In order to solve this, I got to get it down to one trig ratio. So I'm going to make this cosine x over 1. Think of tan as sine over cosine. So this would be, multiply these together, you get sine squared over cosine. Now I see where we're going. Common denominator, LCD, is just cosine x. So multiply this fraction by cosine. It's missing it. Cosine squared over cosine, and then sine squared over cosine. Oh, all this still equals 2. So all I'm doing is just changing the left-hand side. I end up with 1. That's an identity. Cosine plus sine squared. Cosine squared plus sine squared is 1. Pythagorean identity. The most common Pythagorean identity. Sine squared plus cosine squared is 1. I get 1 over cosine x is equal to 2. Let's do the reciprocal. Cosine x is equal to 1/2. Reciprocal on this side, reciprocal on that side. Now we're ready. When does cosine equal 1/2? It's basically saying when does the x equal the short leg of a 30, 60, 90? And it's positive. So I'm in quadrant 1, quadrant 4. That's 1/2. This is square root of 3 over 2, negative square root of 3 over 2. If I'm doing degrees, that's 60 degrees going up, 60 degrees backwards. So x equals 60 degrees. Now I can't say negative 60. It's got to be between 0 and 360. So I can't use a negative number. So it's going to be 60 degrees and 300 degrees. And those are your extra notes for section 8-5. 8-5. All I'm going to ask you to do is just turn in those notes. Turn in those notes as an assignment. All right. If you have any questions, you can email me questions, or I'll be opening Zoom during class. Thanks.